We're going to use slope now as a rate of change, so actually get into it. So if you're traveling in a car at a constant speed of 50 kilometers per hour for a length of time, you will have traveled 50 kilometers in 1 hour, 100 kilometers in 2 hours, 150 kilometers in 3 hours, and so forth. If you're going 75 kilometers an hour, well, the first one you go 75, the second one you go 150, etc. You can plot these rates on a graph with time as a horizontal axis. So here's our time, and distance on the vertical axis. Here's our distance, and you're going to get straight lines. So here we're going 50 kilometers in 1 hour. So we travel 1 hour, we go 50 kilometers. We travel 2 hours, we've gone 100 kilometers. 3 hours, we go 150 kilometers, and so on. This is 50 kilometers per hour. You'll notice before we had an X and a Y axis, now we have a T and a D axis for time and distance. Now in our other case for 75 kilometers an hour, the first hour we went 75 kilometers. In 2 hours we went 150. In 3 hours we would go, this is kind of a little bit off, but anyways, this is our line here. It should be 225. Oh, no, because we're going up by 25s, pardon me, so it'll be 225, etc. We can join the dots because this is a continuous function. We're not sitting here in Winnipeg and suddenly instantaneously an hour later we're 50 kilometers away. We gradually got closer, so we connect the dots here. Okay, so it's important to know when to connect the dots to and when not to. So if you choose any 2 points on this solid line here and calculate the slope, your fraction will always reduce to 50 over 1. Same way, if we did the same thing with this dotted line here, if we took these 2 dots and calculated the slope with them, it would be 75 over 1 every single time. So the slope of the line is the rate at which you are traveling. So the rate of change is distance to time here. Time is what we call the independent variable. The independent variable will always be graphed on the x-axis, and that's the thing that's not depending on anything else. Time moves along at its own pace regardless of what happens around it. The distance is the dependent variable, so how far we go depends on how long we've traveled. Okay? So independent variable is a variable whose value can be freely chosen and which is not dependent on any other value. A dependent is the variable whose value relies on the value of another variable. So always think about which one depends on the other one. In this case, how far you go depends on how long you have driven. Here we can write the relationship between distance and time. Distance 1 equals 50 times the time that you've traveled. Distance 2, so for the second, the dotted line, would be 75 times the time that you've traveled. Okay, so let's look at an actual example. Okay, so Willard works as an electrician's assistant, and he earns $12.25 per hour. So this is a rate right here, $12.25 per 1 hour. An equation that demonstrates this relationship is E equals 1225 times H, where E is the earnings and H is the hours worked. So we want to graph this equation using a table of values. So we're going to use this table here to do the table of values. So if he's worked 0 hours, well, they're not going to pay him. He gets $0. If he works 1 hour, he gets $12.25. If he works 2 hours, he's going to get 2 times $12.25, so he's going to get $24.50. If he works 3 hours, we can add another $12.25, so he's going to have earned $36.75. If he works 4 hours, he's going to be at $49. If he works 5 hours, he's going to be at $61.25. And if he works 6 hours, he's going to be at $73.50. Now, in my head, I just added 25 to each of these. Another way you could calculate it is 2 times 1225, 3 times 1225, etc. And you should always get the same answer. So if I took 5 times 1225 and put in my calculator, I would get 6125. So we want to graph the equation using table of values. So we are going to put these on the graph. So 0, he gets 0. After 1 hour, he gets $12.25. Well, this would be $15 here, so $12.25 would be somewhere around there. After 2 hours would be $24.50, so that's almost $25. I don't know why it's doing that. After 3 hours would be $36.75, so a little over $35. Oh, they all disappeared. Lovely. Okay, so let's put them back on. $12.25. And then we got $24.50. These keep disappearing on me. I'll just have to do them quicker, I guess. $49 is almost $50. $61.25 is just over 60, and then $73.50 would be about there. So what is the slope of the graph? Well, and we should, kind of debatable how you would connect the lines here, but we will, because Willard can earn, or he can work for half an hour, he can work for 15 minutes. Now, typically you don't get paid per minute that you work. You usually get paid maybe per quarter hour, per half hour, but we'll connect it just because it is a continuous thing. Okay, so what is the slope of the graph? Well, we can say m is equal to y2 minus y1 over x2 minus x1. We can pick those points from the graphs. We have them here, so let's just pick some. Let's make this maybe, these are our x's, so this, well, would be h's, but there are independent variables, so this would be maybe our x1, and this could be our x2, y1 and y2. So in this case, our y would be like e2 minus e1 over h2 minus h1. I'm not worried about you writing it that way. I want you to understand that this works. Also understand that we have these variables here. I'm more worried about, let's put the numbers in correctly. So 36.75, minus 12.25 is the same as 3, or over 3 minus 1. So we do 36.75 minus 12.25, and we're going to get 24.50 over 2, and that's going to be 12.25 over 1. Any two numbers we would pick, any 2 points, we would always get that it's 12.25 per 1 hour all the time. That's going to be our slope. And it's positive, it's going up. He's earning more money the more he works. Thank goodness. How much will Willard earn in 7 hours? Well, he's earning $12.25 in 1 hour. How much would he work in how much would he earn in 7 hours? You cross multiply, you'd just be 7 times 12.25 divide by 1. We don't need to do that, but 7 times 12.25, and we would get that he's earning, $85.75. And if he earned $183.75 on a job, how many hours did he work? Well, there's a couple different ways you can do it. Essentially, the math will be the same in all of them, but let's set it up as a proportion. So he's getting $12.25 for 1 hour, and he earned, what was it again? $183.75. The money's on the top, so the money stays on the top. $183.75 for how many hours? Well, y is going to be equal to 183, oops, put the decimal where it didn't belong, 0.75, there we go, times 1, which is just 183.75, divided by 12.25. So you might have also thought, well, if he's getting 183.75 in total, he's getting this much per hour, I can just divide them, and yeah, you're right, and that'll tell you how many hours he worked. So 183.75 divided by 12.25 will give you 15. So he worked 15 hours. And here we should say he would earn $85.75. I hope you can read that.